Hello guys, how are you? Hope all of you are well. This is Devdut Mitra from Chemistry A to Z channel. It was my second effort where I am trying to determine the closest approach of an alpha particle which is thrown towards the nucleus during Rutherford's alpha scattering experiment. So first we will understand what do you mean by the term closest approach. The distance of the closest approach can be defined as the minimum distance of the charged particle, that is, charged particle means alpha particle, from the nucleus, at which the initial kinetic energy is the same to the potential energy of the nucleus. The picture, if I'll make you show the picture, then it is like here the point A at infinite distance from the nucleus. At point A, alpha particle has high kinetic energy, but potential energy is equal to 0 because it is situated at point A where velocity is where its potential energy is 0. But if we assume at infinite distance from the nucleus, say at point A, if v is the initial velocity of the alpha particle, then kinetic energy expression will be half mv square. So the total energy at point A of alpha particle is its kinetic energy, and potential energy is nothing but the electrostatic force between two positively charged particles, that is, one is alpha particle approaching towards the nucleus and another the nucleus by itself, another positive charged particle, right? At point B, here the picture, kinetic energy here it would be 0. Why? Because velocity, that means as much as the alpha particle approaches towards the nucleus, it would be the under repulsion force emerged by the nucleus, because alpha particle and nucleus both have positive charge. So the velocity will be reduced as much as it would be closer to the nucleus. At the point B, alpha particle, the velocity of alpha particle will be 0, as well as kinetic energy of alpha particle will also be 0. Okay guys, I hope that you understand why the kinetic energy at point B should be 0. But here, due to repulsion force, potential energy of alpha particle will be highest, will be high, very high potential energy. Okay, that means at point B the alpha particle will retrace its path again. So if U represents the potential energy which is given by force, this F represents the electrostatic force. I am writing here, it is electrostatic force it is given by minus du by dr. That means du here is the derivation or incremental change in potential energy in joules, and r, that means dr, not r, it is dr, it represents the incremental change in separation, whose units in meter. Okay, so at point A here, kinetic energy of the alpha particle is equal to half mv square, but potential energy at infinite distance, that is u infinity, u represents the potential energy, so u at infinity will be 0. At point B, kinetic energy of the alpha particle is equal to 0. So potential energy at point B, that is u of B, B means at point B, the potential energy at point B is equal to the electrostatic force, right? So we may write UB is equal to kappa into Q1 by Q2 by R square, and kappa into Q1 into Q2 by R square, that would be equal to minus du by dr. Okay, on integration both sides, that is here. Okay, one thing more, what is kappa? Kappa is the dielectric constant of the medium whose value can be represented by 1 by 4 pi epsilon. Epsilon is the absolute permittivity of the medium, and the value of kappa in SI system, it would be 9 into 10 to the power 9 Newton meter square by Coulomb square, whereas the value of kappa in CGS will be 1. Okay, so what will we get by integration? That is minus kappa into Q1 into Q2, because kappa into Q1 into Q2, it is a constant, so it has no change, and we know about integration. Here upper limit is infinity, lower limit is r, corresponding to u at infinite distance, u will be 0, but at distance r it would be u. So after putting all of these values here, we get the expression for potential energy in terms of electrostatic force, that is kappa into Q1 into Q2 by R. On the basis of the law of conservation of energy, the energy of alpha particle at point A exactly equal to energy of alpha particle at point B. So at point A, energy of alpha particle, that is E of A, can be represented is the summation of potential energy and kinetic energy, that is potential energy at point A, where at point A potential energy, that is at infinite distance, potential energy will be 0, kinetic energy will be half mv square. Okay, hope you understand that why it would be 0, because at infinite distance potential energy, alpha particle has no potential energy, it has only kinetic energy, and at point B, energy of alpha particle, that can be represented as E of B, E for energy, summation of potential energy plus kinetic energy, but we know 0 kinetic energy will be 0 at point B, it has only potential energy. So Q1, instead of Q1, 2E represents the charge of alpha particle, that is helium nucleus, and instead of Q2, if Z is the atomic number of the atom, then ZE represents the nuclear charge, right, divided by R. So as we know that EA is equal to EB according to law of conservation of energy, so we may write 2 kappa Z square by R is equal to half mv square. Therefore R is equal to 2 kappa Z square by half mv square, we may get 4 kappa z square by mv square, or r is equal to 2 kappa z square by kinetic energy. This is the expression of the closest approach, the distance of closest approach of alpha particle which is thrown towards the nucleus. On the basis of this formula, we want to make you show few numerical problems. Okay, so here an alpha particle, after passing through a potential difference of 2 into 10 to the power 6 volt, falls on a silver foil. The atomic number of silver is given as 47. Now we have to calculate the kinetic energy of the alpha particle at the time of falling on the foil. Okay, and there are three parts. Second, we have to calculate kinetic energy of the alpha particle at a distance of 5 into 10 to the power minus 14 meter from the nucleus. You may note down if you want. You may note down the total problem. Here it is. So the first one, that is, if we want to find the kinetic energy of the alpha particle at the time of falling on the foil, here it represents a cathode and it is positively charged anode, and if V volt is the potential difference between cathode and anode, then we may write, if V volt is the potential difference between the cathode and anode, then V be the speed acquired by the electron. That means from cathode, electron as ejected, it will run towards the anode. Therefore electron must have some kinetic energy. So gain in kinetic energy of the electron, that is, an electrical work is to be done. That means kinetic energy is equal to charge of electron, that is E, and potential difference V. It is the electrical work done. So from the expression of kinetic energy, that is half mv square is equal to E into V. V is the potential difference between cathode and anode, where E is the charge of electron, and small v represents the velocity acquired by the electron. So V square is equal to 2 into eV by m. Therefore expression of velocity V is equal to square root of 2 eV by m. Here velocity in an electric field where V volt express its potential difference. M is the mass of the electron, right? Here by the problem, the potential difference is given as 2 into 10 to the power 6 volt, and the charge of alpha particle, that is double positive charge helium nucleus, is 2e. Charge of silver single plus is 47 into E. 47 is its atomic number, that means proton number, whose charge E. Therefore kinetic energy of the alpha particle at the time of falling on the foil, that is 2 eV, is equal to 2 into value of charge of electron is 1.602 into 10 to the minus 19 coulomb into potential difference, that is given 2 into 10 to the power 6. So we get the value, the first answer, 6.4 into 10 to the power minus 13 joule. Hope it is clear to all of you, and we have learned a new formula how to calculate the velocity of an electron ejected from cathode and running towards the anode due to electrostatic force of attraction in presence of a potential difference V. So it would be an important formula. Okay, now if we want to calculate the second answer, second part of the question, kinetic energy of the alpha particle at a distance of 5 into 10 to the power minus 14 meter from the nucleus. So here say this is the infinite distance of alpha particle. As much as the alpha particle approaches towards the nucleus, its kinetic energy will be decreases, but potential energy will be increases. Okay, therefore we can write kinetic energy of the alpha particle at the distance of 5 into 10 to the power minus 14 meter from the nucleus is equal to kinetic energy plus potential energy. So potential energy is nothing but electrostatic force between two positively charged particles. So kappa z square by r, negative of kappa z square by r, is the potential energy representation. So putting all the values of kappa and nuclear charge of the atom and silver atom, we get here 4.3 minus, it is minus 4.34 into 10 to the power minus 13 joule. Therefore total energy will be, here we will already got the value of kinetic energy, here it is, of the alpha particle at the time of falling on foil, that is 6.4 into 10 to the power minus 13 joule. So total energy will be potential energy plus kinetic energy. Therefore kinetic energy expression that we have got 6.4 into 10 to the minus 13, and the potential energy, here we have already calculated potential energy minus 4.34 into 10 to the power minus 13. So putting this, we get 2.06 into 10 to the power minus 13 joule. This is the answer of part 2. Therefore we may write here the kinetic energy of the alpha particle at a distance of 5 into 10 to the power minus 14 meter from the nucleus is positive energy, right? Here it is positive. Now let we move the third part of the same problem. Here the shortest distance from the nucleus of silver to which the alpha particle reaches. So here I have written the question again. Putting the value of the closest approach, it will be r, not r0. R is equal to 2 kappa z square by kinetic energy that we proved earlier, that we derived earlier of this video. So here m is the mass of the alpha particle. Here it is. Putting all the values of kappa, z and e square divided by kinetic energy, that is 6.4 into 10 to the power minus 13, we get the ultimate value. This represents the shortest distance, 3.39 into 10 to the power minus 14 meter. This represents the shortest distance from the nucleus of silver to which the alpha particle reaches. Here it is alpha particle whose charge is 2e. At point B it will retrace after striking the B point. Okay, so this is the R represents the closest approach, not here. It is the closest approach here up to this B point. Okay guys, the next one, a beam of some kind of particles of velocity 2 into 10 to the power 7 meter per second is scattered by a gold Z, that means proton number 79, gold foil. We have to find specific charge of this particle, that is charge by mass ratio, if the distance of the closest approach is 7.9 into 10 to the minus 14 meter. Here the closest distance is provided to us. We have to calculate E by M ratio. So at the closest approach to the nucleus, due to the conservation of energy, we know kinetic energy of the particle is equal to potential of the energy of the particle. Kinetic energy expression half mv square, and potential energy is nothing but electrostatic force of attraction, that is kappa q1 into q2 by r. Okay, so v square by r by 2 kappa qz is equal to E by M, where q2 is the Ze, that is nuclear charge, and q1, that is the charge of electron. So v square by r by kappa into q1 into q2. Okay, we get E by M. So therefore, putting values of velocity, that is 2 into 10 to the power 7 provided in the numerical, and r, the closest approach, 7.9 into 10 to the power minus 14 divided by mass of the particle, E by M. 2 into 9 into 10 to the power 9, that is the value of kappa, and charge of electron is 1.602 10 to the minus 19 into 79. We get the value 1.39 into 10 to the power 8 coulomb per kg. Okay guys, I hope that all of you understand, and if you like the video, please subscribe my channel. As much as you subscribe, it is the inspiration of me to make such type of videos for you. Okay, thank you, bye.